Assalamu alaikum. Today on 6th November 2020, I am starting lecture number 1 for week number 7, and the topic of my lecture is numerical problem involving transformer circuits. Earlier in your subjects LCA, that is linear circuit analysis, and ENA, that is electrical network analysis, you have performed a lot of circuit analysis procedures such as performing KVL, KCL, current division rule, voltage division rule, node voltage method, mesh current analysis, Thevenin theorem, Norton theorem, maximum power theorem, superposition theorem, etc., etc. There are a lot of circuit analysis techniques that you already know. But what is the difference in this numerical problem as compared to all those numerical problems you have performed earlier? This problem involves transformer in it. For the very first time, you will solve a numerical problem and you will calculate current, voltages, and power losses in a circuit where we will be using two transformers. So how can we solve the circuits involving transformers? We will learn this in this numerical problem. As usual, the author every time he gives a numerical problem, there always a hidden electrical engineering concept in it. For example, in this numerical problem, if you notice in the first figure, that is figure A, what we have with us that there is a generated voltage on the left side of the figure. So the generated voltage is 480 volts, and right after generation there is a portion of transmission line where what is happening that without using a transformer we are transmitting the generated electrical energy through a transmission line of impedance 0.18 ohm plus J time 0.24 ohm. So we are not using a transformer, and right after generation we have transmission line with us, and using this transmission line we are feeding a load of 4 plus J3 ohm. Now what will happen in this scenario? We have generated electrical power, we are not using the transformer, and we are directly sending it to the desired load. So there will be two disadvantages of this scheme. Not using the transformer will be giving us two disadvantages. What are the two disadvantages? Number one, we have generated 480 volts, but we will inshallah we will perform this calculation sometime later, that the load voltage we received in this scheme is basically 454 volts. 454 volts. So this is a disadvantage of not using the transformer. Why? Because we have generated a voltage of 480 volts and we transmitted it through a transmission line to some distance. But what happened that when we received the voltage at our desired load, it was dropped 26 volts. The original voltage, the established voltage, the generated voltage was 480 volts, but we received only 454 volts at our load. So this is a common practice in electrical power. In your own area, you might observe this thing, that what happens that if in an area the transformer is of low specifications and there is more electrical load as compared to the transformer specifications, what happens that the homes or the offices nearer to the transformer will be getting appropriate or full voltages, but the homes or offices that are a bit far as compared to other homes that are nearer to the transformer, so they will be having low voltages in their homes or offices. So due to this low voltage problem, their home appliances or electrical devices may perform malfunctioning, or even they may be burnt out. Na? So this is the disadvantage of not using the transformer. So in a part, what they want you to realize, that if we will not use a transformer, number one, we will face low voltage problem in our electrical power system. Now, what is the second disadvantage of this scheme? The second disadvantage of this scheme is that there will be more I square R losses. There will be more line losses in this situation when we are not using a transformer. So in a part, they basically plotted that what are the problems that our transformer is addressing. So transformers are making sure that we will provide full voltages to our desired loads. Number two, transformers are ensuring efficient long distance transmission of electrical energy, because when we use a step up transformer, it steps the voltage up, and uh, at the same time it steps the current down, and since the transmission line losses are proportional to the square of the current, so if uh, current is being reduced, so square of the current being more reduced, and hence what will happen, that we will not be having much I square R or much line losses. So in the second part of this example, that is the B part, you can clearly notice that there are two transformers, one at the generation side. This is the first transformer, and the other at the load side. So what is happening, that right after generating 480 volts, the author has used one transformer to step up the voltage 10 times and at the same time step down the current 10 times. So what happens, that in the line current is 10 times reduced as compared to the generated current. So the line losses, that are the I square R losses, are reduced. And when it comes to the load side, the author has used another transformer to step the voltage down and to step the current up at the same time. So what happens, that in this situation, when we are using two transformers, rather than getting 454 volts, this time we are getting 479.7 volts, that are almost equal to the generated 480 volts. And rather than getting a high transmission line losses of 1484 watts, in this situation we are getting a loss of 16.7 watts only. So hence what we can conclude, that in electrical power transformers, in electrical power transmission, transformers are basically playing a vital role. because they are reducing the line losses at the first place. And what is the consequence of and what is the basically effect of this thing? The effect of reducing the line losses is that we can provide our load with desired voltages. As told earlier, that in a dam, what happens that right after the generator, there is a huge transformer known as the unit transformer, which steps up the voltage from the from the generation level to the transmission level. Sometimes this transmission level voltage may be of 432 kilovolts or more. So in this example, we are just stepping up the voltage 10 times, and still we are uh, almost near to the generated voltage. So imagine if we are using a transformer of such specification, which is basically converting 2.5 kilovolts to 432 kilovolts. So how efficient that transformer will be? So in electrical power engineering, line losses are negligibly small. So now coming